Hi everyone, today we are going to discuss class 11 chemistry textbook, first unit 12. The topic is organic chemistry and some basic principles and techniques. Okay, actually organic chemistry is mainly, you can say it is a chemistry of carbon atom. So carbon is known as magic element, okay, because we have to study a whole book or whole topic only about carbon, and the part is known as organic chemistry. Okay, because carbon can make single bond, it can make double bond, or it can make triple bond. Same carbon, different condition, it can make different bond, and it can also make bond with itself in long chain. Okay, and interestingly, carbon can make also bond with other atom like oxygen, nitrogen, sulfur, and with metal also. And it can also make cyclic compound in between itself and with other compound also, other element also. First, it was thought that organic compound cannot be synthesized in laboratory. Okay, some vital force is needed to do such kind of reaction. But later, when urea, okay, NH2CO, NH2, and acetic acid has been synthesized from inorganic sources in the laboratory, then it is realized that yes, organic compound can be synthesized in lab. So this is acetic acid. Now we are going to discuss about the shape of carbon compound, okay, and the tetravalence of carbon and shape of organic compound. Carbon can make different kind of compound, I mean different hybridized compound. The methane, it is sp3 hybridized, and ethene, okay, C2H4, it is sp2 hybridized, and ethane, C2H2, it is sp hybridized. So here how different compound has been formed, different hybridized compound has been formed. It is we can understand this by look at electronic configuration. Here in 2s 2 electron, and in p orbital there are 2 electron, so there are 2 electron and 2 electron there in p orbital. Now it is in ground state, but in excited state the electron in s orbital goes to the p orbital. Okay, as a result, now we can make hybridized orbital. So here when s and 3p atomic orbital combine, then sp3 hybridized, s and 2p orbital combine, then sp2 hybridized, I mean 2 electron from p atomic orbital and 1 electron from s atomic orbital, and if one from s and one from p, then it will be sp hybridized. Now we are going to discuss about the electronegativity. As the sp3 hybridized compound in methane, the carbon is most less sorry, here you can clearly see that the sp hybridized orbital have 50% s character. Here this hybrid orbital contains more s character, and hence it is closer to its nucleus, and as a result it can form stronger bond and short bond, and definitely it will be stronger bond in comparison to sp3 hybridized and sp2 hybridized orbital. And this is due to the electronegativity of s character also. As we know, the s orbital are more electronegative than p atomic orbital. So this relative electronegativity is reflected in several physical and chemical properties. Okay. Now we are going to discuss about pi bond. Okay, pi bond. Let us take an example of ethene molecule. Here you can see two bond is there, one is sigma bond and one is pi bond. Okay, as we know, here these two carbon atom are sp2 hybridized. Okay, so here in this carbon, two p atomic orbital participate to form sp2 hybridized orbital, and the remaining p atomic orbital in this carbon and in this carbon will involve in pi bonding formation. So here these two p atomic orbital will overlap parallelly and they will make the what? Pi bond. So it will be look like, if this is the plane of the molecule, then the pi molecular orbital will look like this. The electron density will be above the plane and below the plane. So if now we rotate the molecule along this bond, then it will what? It will hamper the overlapping of two p atomic orbital. So it is not possible, or it is very difficult to rotate the carbon-carbon double bonded molecule along the sigma bond without breaking the pi bond. Now we are going to find some sigma bond and pi bond in some molecule. Let us take an example. Suppose in this molecule CH3 CN. Okay, this compound will look like carbon, hydrogen, 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 carbon, triple bond, nitrogen. So this compound, sorry, this carbon will be definitely sp2 hybridized, sp3 hybridized, as there are 4 bond. Okay, so there are here also one s3p, so there are 3 hands in this hybridized orbital. So one hydrogen, sorry, 1 2 3 4, so total 4 bonding, 1 2 3 4. Okay, now this carbon is sp hybridized. So how it is possible? So we are going to see only the carbon atom hybridization. So here if we take the electronic configuration, then we can see that in carbon there are 4 electron in the valence shell, as its atomic number is what? Atomic number is 6. So valence electron in the excited state will be look like this. So here there are 2 pi bond and 1 sigma bond. So how to make it possible? So it is what? It is sp hybridized, and these two p atomic orbitals, suppose if it is px, then it will be py and it will be pz. So this py and pz atomic orbital present in this carbon atom will form what? Pi bond with nitrogen molecule, and same case happen in case of nitrogen also, but here we are going to discuss only about carbon atom. So this two bond is formed due to the overlapping in between py and pz atomic orbital of carbon with p atomic orbital, 2 p atomic orbital of nitrogen. Okay, so it is sp hybridized. Let us take another example. Suppose it is HCONH2. If we write down the complete structure, then it will look like CONH. Okay, now here we have to see the hybridization in carbon. Okay, here you can see there are 3 sigma bond. Yes or no? This is one sigma bond, this is another sigma bond, and in between these two one is another sigma bond. So here one pi bond is there and 3 sigma bond. And how to make it possible? For that we have to again draw the electronic configuration. How it look like in the excited state. Again, here one electron, here also one electron, as there are 4 electron. So how to make it possible? 3 bonding. So for 3 bonding we have to make 3 single electron to make hybridized atomic orbital. So one s and 2 p. So this is p, sorry, this is s, this is, sorry, this is s twice s, this is px, py and pz. Okay, so here px, py and s, these 3 will atomic orbital will participate or hybridize to form sp2 hybridized orbital. And here there are 3 hands, so these 3 hands will form 3 sigma bond 1, 2 and 3, and the remaining pz atomic orbital will form a pi bond by overlapping with another p atomic orbital of oxygen atom. Okay, dear student, now we are going to discuss complete 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 and condense and bond line structural formula. Okay, let us take an example of what, propane molecule. Here, as we know, there are 4 carbon atom, sorry, 3 carbon atom present here, propane. So complete structure, we have to write down all the bond and all the atom here. So we have to write down all the hydrogen atom with their bonding and all the carbon atom with their bonding. So it is complete structure. Okay, carbon hydrogen bond should be depicted, carbon carbon bond should be depicted, so it is complete structure. Now if we want to draw the condensed structure, then only we need to show the carbon carbon bonding, and we don't need to show the carbon hydrogen bonding. We can make it in condensed way or in a shortcut way. So it will look like CH3. We can write here 2 bond CH2 and CH3 like this. So it is a condensed structure. Now the bond line, here we no need to write any kind of bond, just we can make the skeleton of the compound. Simple, it will be look like this. This is the bond line structure for propane molecule. Okay, let us take another example. Let us take one little bit complex example. OH CH CN2. If we will write this structure, then we can first let us draw the complete structure. OH bond will be there, and after oxygen it is carbon. So simple, you don't need to worry about this. After that, what will come? Hydrogen. So let us draw the hydrogen bond. After the 2 cyanide will come here. So cyanide will be look like this. So 2 cyanide, in this carbon 1 hydrogen and 1 hydroxyl. So it is the center carbon. Now it is the complete structure. Now we are going to draw the condensed structure. Then how it will look like? It will be very simple. We don't need to write the bond except the carbon carbon bond. So it will be look like OH cyanide. So it will be the condensed structure. And here you can see there is no carbon hydrogen bonding, and there are no carbon carbon bonding here. So here we have to write this. Here another element is there, nitrogen, in both cases, so we cannot draw the skeleton like before. In case of propane we write like this, but here we cannot write like that, so we have to write all the all the functional group cyanide, 2 cyanide here, and hydroxyl. So this structure is for both bond line and for condensed structure. Now now let us take another example given in the exercise: isopropyl alcohol. Okay, isopropyl alcohol. So here propyl, that means 3 carbon atom, and alcohol, so we have to write first the complete structure: OH, CH3, CH3, and hydrogen. This is isopropyl alcohol complete structure. So now the bond line structure will be like, we don't need to draw this bonding now because it is bond line, so we don't need to write the carbon atom, we have to write the only bonding. So it will be look like what? So simple, just like this, because the hydrogen should not be there, only carbon atom should be there. So 1 carbon, 2 carbon, 3 carbon, and it is hydroxyl. Another example: 2,3-dimethyl 2,3-dimethyl butanol, dimethyl butanol. Okay, so butanol means what? 4 carbon will be there, 1 2 3 4, and butanol, aldehyde, so this carbon, first carbon, will be definitely aldehyde group. And here 2,3-dimethyl, so if it is 1, then definitely it will be 2, and this carbon will be 3, so 2,3-dimethyl butanol. Okay, now we have to write the bond line structure. This is not the complete structure, okay, because we have written this in a complete structure form. So now according to the exercise we have to write the bond line structure. So very simple. First of all, we must have to write the aldehyde group first, because it is carboxylic functional group, so we have to write functional group. Then 1 2 3, so 1 2 3, and in 2 position 1 methyl group, and in 3 position 1 methyl group. So this is the bond line structure for 2,3-dimethyl butanol. Okay, clear?